Hello and welcome to Dunia's Alchemy. Welcome to another GCSE Chemistry lesson, and today's topic is atomic structure. The video breakdown is below. We're going to look at structure of the atom and calculating PEN. Now what's PEN? PEN is your protons, electrons and neutrons. Second thing we're going to look at is the history of the atomic model. Third is the electronic structure. And fourth, we're going to look at isotopes and relative atomic mass. So let's begin. Elements are made up of one type of atom. An atom is the smallest particle in an element, and it contains all the properties of that element. If I was to zoom in and look at the structure of the atom, I would firstly see that this central part in the middle is called a nucleus. Inside the nucleus, we have protons and neutrons, and orbiting in these things called shells, we have electrons. These are your three subatomic particles: neutron, proton, electron. You need to know this table where it tells you the relative mass and the relative charges of each one. Neutrons are neutral, meaning they have no charge. Protons have a +1 charge, P for proton, P for positive. Electrons are negatively charged, so -1. When it comes to the mass, protons and neutrons have the same mass, which is 1, and electrons are many times smaller, 1/2000. Electrons are the smallest of all three. Now that we've just looked at the structure of the atom, I'm sure you could tell me what I mean by PEN. In the periodic table, you would be given this information for every element. So let's look at what each part tells us. The first part tells us the mass number, and that is essentially the number of protons and neutrons. And in brackets here, I wrote P plus N. Na, in our case, is the element symbol. And then underneath, you're told the element name, then the atomic number, and that tells you the number of protons or electrons. In the exam, you can just say tells you the number of protons, but I've left all electrons here for this next part. So let's actually try to calculate PEN. Finding the protons, you always look at that bottom number, your atomic number, and therefore the answer is going to be 11. Next, your understanding is proton number is equal to your number of electrons. That's why I said number of protons or number of electrons. So my electrons are going to be 11. And finally, we're going to calculate the number of neutrons. I gave you some information on neutrons right at the top where it says mass number. And that tells you the number of protons and neutrons. So what you need to do is you simply take the mass number away from the atomic number. 23 at the top, take away 11 gives you 12. Let's try this quick quiz. Pause the video and try to calculate PEN for each of the following. So let's see if you got the right answer. The first one is 13, 13 and then 14. Next, for potassium, it was 19, 19 and then 20. And finally, for neon, it's 10, 10 and then 10 again. People didn't used to think of atoms the way we do now. The model of the atom has evolved over time, and you're expected to know the models and the scientists who contributed to their creation. You do not need to memorize the dates, but you do need to know the order. So let's begin. First, we have Dalton's model, and that is the solid sphere model. Dalton stated that atoms are tiny indivisible spheres that make up all substances. He argued that atoms of each element are identical and combine in fixed ratios to form compounds. Next is Thomson's plum pudding model. Thomson discovered the electron and proposed that atoms contain negatively charged particles. He suggested atoms were spheres of positive charge with electrons embedded inside, like plums in a pudding. Rutherford's nuclear model came next. Rutherford's alpha scattering experiment, which we're going to look at shortly, showed that most of the atom is empty space. He concluded that atoms contain a small, dense, positively charged nucleus at the center. Bohr's planetary model. Bohr proposed that electrons orbit the nucleus at fixed distances, in defined energy levels. He stated that electrons can move between these shells by absorbing or releasing energy. And finally, Chadwick's discovery of the neutron. Chadwick discovered the neutron, a neutral particle found in the nucleus. This explained the atom's additional mass and led to the modern nuclear model, which we've learned at the beginning of this video. So let's have a look at the alpha scattering experiment we mentioned earlier. Alpha particles, as I've shown on the right over here, are made up of 2 protons and 2 neutrons. So overall, they have a 2+ charge. It's also called a helium nucleus. Essentially, these alpha particles were fired on gold foil. Based on the results from the plum pudding model, we expected the positively charged alpha particles to pass through the atoms. However, what actually happened was quite different. Majority of them actually did. However, a few of them were deflected. and a small number were deflected backwards. And that got him thinking, why? Since the alpha particles are positive, they would only be repelled from another positive region, like two north-facing magnets. This led to the discovery of the nucleus. Based on the results from the plum pudding model, we expected that the positively charged alpha particles would pass through. Majority did, however a few deflected from the straight trajectory and a small number deflected backwards. Rutherford upgraded the model to fit these findings, and that's how he came up with the nuclear model. He explained how the small portion of positive alpha particles that got close to the positive nucleus would be repelled, and depending on if they were nearby or directly facing the nucleus, it would deflect away. We are now going to have a look at electronic structure. So the first shell is supposed to contain a maximum of 2 electrons. The second shell, as you can see, holds a maximum of 8 electrons, and the third shell holds a maximum of 8. So if you're asked to give the electronic configuration, you'd write it as 2, 8, 8. And of course that would vary for different atoms, however that is the maximum capacity that you need to know. Definition for isotopes is a very, very popular exam question, so you need to make sure you know this. Isotopes are different atomic forms of the same element, and they have the same number of protons, but a different number of neutrons. How do we calculate relative atomic mass? The way we calculate relative atomic mass is shown over here. So you multiply the mass and the abundance of your first isotope and add that with the mass and abundance of the second isotope. And if you get 3 different isotopes, you just add that in, and that's why I left the ellipses at the end. Let's try an actual exam question. Calculate the relative atomic mass of a sample containing 2 isotopes of copper. It's made up of 69% copper 63 and 31% of copper 65. Feel free to pause the video and calculate this. Plug everything into our equation from earlier. So the mass of the first isotope is 63, as you can see, copper 63, and you'd multiply that with 69% because that's your abundance. And you'd add that to the second isotope, which is copper 65, multiplied by the 31. You divide all of that by 100 because that's your total abundance, and that should give you 63.6. I have left some exam questions to answer. They're 30 minutes in total, and I've separated them into bronze, silver, and gold. Pause the video and answer these. The answers will appear shortly. Good luck. Now, although I did say it takes 30 minutes, it's actually out of 31 marks. So give yourself a total out of 31. Feel free to tell me your score in the comment section, and also if you found this helpful. Well done. That is our video complete. We have now gone over the structure of the atom and calculating PEN, which is our proton, electron, neutron. We've looked at the history of the atomic model, which is a very famous exam question, electronic structure, and also isotopes and calculating relative atomic mass. Hope you found this video helpful, and make sure you do the 3-2-1, share it with 3 others, give it 2 clicks, like and subscribe, and also leave 1 comment. Have a great one.